Hello everyone, my name is Misael Uzcategui and I'm about to present the core review for SciHelper. Just to give a little background, SciHelper is a product that is intended for helping blind people with low vision, and the idea that is combining computer vision with machine learning. So it's actually integrating preset model that read image and try to identify the object that is on the image. The architecture that is behind is pretty simple. Basically, it has a model, and for this case, we're using the CAFE model. Has the CAFE protext. This is how the neural network that works inside is built. AY drivers. These are basically the drivers that make possible the interconnections inside with all the peripherals and the OpenCV drivers. The whole project is actually based on Python. Going in more details, we have the base ground that is made from the Google White Kit, the voice kit version 1. This is actually built to works in any type of project inside Raspbian. So it's pretty straightforward, the guide that you can build. So it comes with a preset of materials. The main important parts are actually the head and the speakers for this project. Specifically, they can be attached directly to the Raspberry Pi 3. It also already comes with an assembly guideline that comes with a setup Raspbian with all the drivers set up for ready to work in this process. Going further in detail for the code itself, you can see how it's already built. The AY drivers are actually in the AY folder, but everything is already built inside. The next step is actually the model itself. There's is already a precompiled model, and then it's actually the prototext that contains how the neural network is built inside. Going back, we have the actual code that makes everything happen. So we have the baseline, how the code could run. We have the preset packages that we will need to be able to run the complete process. So the first step that we need to do is to set up the Pi camera resolution. That's what we do over here. The idea of 320 and 240 is based on the papers that said that this is the lower quality resolution that we can go to have also a good rate of recognition. The next step is to initialize the voice engine speaker. That's going to be initialized using the PyText library. So after we already have an engine, we set the rate of the speed, how it's going to be pronouncing every object that has been detected, and also the volume that has to be reached. After we already set up the volume and the rate, we make sure that the language that we're using the engine is English in this case. After that, we look forward for the arguments that are going to build inside the program. This is basically setting up the prototext to build the neural network, and also the model itself that is going to be running through the neural network. To make it in a way simpler, we specify the classes that are going to be recognized in this case, based on the pre-trained model in this case. After this, we start actually initializing everything inside the in memory. At this point, we're actually loading the model and the protext. So after this point, it will not be actually rereading again. Everything is going to be pre-set up for the next iterations. At this point, we're actually engaging the loop. So at the moment that the user start the program, it just start looping and waiting for new inputs. So the way that we control this process is actually by the trigger button. So every time there is trigger, it engages the process of taking the picture, loading the images, and going by the frame. So after we grab the frame, we go through the process of re-engaging the neural network. And at that point is when it passed through the process of detection and the predictions of the object could be engaged inside that picture. Finally, we started after the labels are already preset. We go through the process of speaking out all the elements that has been recognized through the engine, and this is basically the process that works through the list. And if it comes to the case that there's no object that has been recognized, it says no object detected at this point. So after all this process has been done, it goes back over to the loop where it's still waiting for the next iteration when the user press against the button. So just to keep in mind, the first step to setting up all the model and the text and everything to be able to just engage the process of recognition object, it takes around 10 seconds. And after this process has been done, the iteration between taking the photo and speaking out the object recognition, it takes roughly from 5 seconds to 8 seconds. Thanks for paying attention to my project, and I hope you enjoyed. Thanks.